Hey, what's up, guys? So I'm finally back making another video on the super cheap ESP8266 Wi-Fi module. In my last two videos, I showed you how to get some basic communication going with the Arduino and how to pull data off of the internet into your projects using a service called ThingSpeak. In this video, I'm going to show you how to bring it all together and how you can make your projects talk to you from anywhere in the world, and how you can get data from your projects or your things into the cloud from anywhere in the world, and also send data from the cloud back down to your things. So we're going to kind of bring all that together, and I've got a nice lightweight example here to get you started with that. Obviously, this is not going to be an enterprise level sort of installation like something we would do at USA Firmware for an IoT project. But this is a basic example, so we're not going to talk too much about security and things like that. So let me show you what I put together here before we really take that deep dive into the code. Okay, so here's what we've got. An Arduino clone here hooked up to an ESP8266 in the same way you saw in my last two videos, with the potentiometer hooked up here with the wiper on analog pin 0 and an LED hooked up to digital pin 3, and we're going to PWM output that. Over on the website here, this is a web interface I created that you can access from anywhere in the world. It's actually hosted right through my website, and I'm going to show you exactly how this works and how to build this yourself. And we only have one unit here, but if we had multiple things over here, we would have a list of our things, and we could have as many columns here as we want, all kinds of different data. So it's extremely powerful here just with this very crude demo. And we have here the unit ID, so we only have one. And here is our LED brightness. So this is an 8-bit PWM output, so 127 is kind of the halfway point. If we go and make that a 0, over here this is polling the cloud once every 5 seconds. So you see that the LED actually turned off there. So you see that how the blue light there on the ESP8266 kind of blinks once every 5 seconds. That's when it's going out and getting its new data. And you can follow that here. This is the serial monitor window hooked up to that Arduino, and I'm basically running the same exact code you saw in my other examples. So we're doing, the connecting, connected, ready to send, sent, and then it goes and scrapes out the return value. Well, it's actually going and connecting to now a database hosted on my website. And again, I will show you exactly how all of that works. It's also pulling in the time, which I'm not doing anything with, but that's kind of nice to have, because when you're connecting to the internet, that's just something you can pull off of the server, so you might as well just grab it. So I got the time there, the LED value, and then also we have a column here for a sensor value. And that's where this potentiometer comes in. So if I go ahead and increase that a little bit, you'll see that the web interface, which is also being refreshed, see, I can refresh that and get that. So, and you saw it down here in the serial monitor window as well when that increased. So now I want to show you one other quick thing. And if I just put my phone down here, we're going to demo something else. So a little bit of a surprise here. But if we continue to increase this potentiometer past a certain value, you'll see, oh, not quite enough there. Keep going. Let me just max it out. Okay, so now that is maxed out. And if we just give it a second here, we see a new text message just came in from Unit 1. You probably can't see that. Let me hold on one sec. Let me just lower the brightness on my phone here. But we're demoing how to receive text messages from the ESP8266. So basically, as soon as this potentiometer value exceeded 200, and now I'm getting a text message every time it connects. And there's ways, you can sort of interlock that so that you only get one text message, and maybe you have sort of the same thing I had on my garage door monitor system where I had an arm button up in the web interface. So I better actually lower that real quick so I don't get a million text messages. Okay, there we go. So on the next update now, we should see that go down to 0. And there we go. Let's go ahead and change the LED to full brightness here. 255. Okay. And now the next time this goes and connects, we get 255 and the LED goes to full brightness. So that's the demo. Now I want to break into the code. Okay, so the first thing we're going to talk about is the web side. And for this, I'm going to host the code and the database up on my personal website, kevindera.com. And obviously, after I'm done making this video, I'm going to take all of the code down. But it will be zipped up and available for download, so go ahead and see the description below for that. And you can implement the code into your personal website or your server running at home. So anyway, we're using HostMonster here, and that's the company I've been using for years with my site. But I think most host companies are pretty similar to this one. So if you're using something like HostGator, you should have all the same options. So the first thing we need to talk about, though, really here is the database. And one way to think of this is having a spreadsheet that lives in the cloud that we can access and change data to. And so that's kind of like the way this works. You know, we've got rows in this spreadsheet and we have columns in this spreadsheet. The ESP8266 can go in, change that spreadsheet, and then from this web interface, I can refresh it and pull that information out. So that's kind of the way this whole thing works. So let's go ahead and set that spreadsheet up. Okay, so what it's actually called is a SQL database. Okay, so we're going to go ahead and set up a SQL database. And I've already done this for this project, but I'm going to walk you through exactly how you do this. And since I have a lot of other projects on my website, I'm going to have to kind of block things out. And this part of the video is going to seem a little chopped up because I can't, I don't want you to see passwords and other information for other projects I've got going on my site. Okay, so the way you do it is go to your SQL databases and create a new database, and I've already done this, and so I've added ESP part 3, and that's the database I created. Okay, so once you do that, you really don't have to do anything, just create the database. So you want to create a user for that database that can access it, and we created a user called user ESP. Okay, so once you create the user, you give them all the privileges to access, change, read, write to this database. And it's pretty self-explanatory, but basically that's what you do is you first create the database, then you create a user that can access the database with the password, and then you're pretty much all set. Then you go back to your cPanel, and you want to look for something called PHP MyAdmin. Okay, now we're going to be able to go in and modify that database. So this will take you to another user interface here. Kind of takes you out of the HostMonster interface. Select your database from the left, and you want to create a new table in that database. And this is the actual spreadsheet we're going to be modifying. So I already did this, and we're calling it ESP table. So once you create the table, you open it up, and you'll see that you have 3 columns there. And I already created these columns, but I'm going to go in and show you the structure there so that you can copy your table exactly like this. So the ID here is an auto increment. So when you see that, let me go in and actually show you what that looks like. So you'll see something that looks kind of like this, and then you just check the auto increment. And the reason you do that is so that it auto increments this ID so that the more units you create, they just go 1, 2, 3, 4, and so on. Okay, we have the LED column and we have the sensor column. And these are all integers as the type. And you could also add columns here. So if I wanted to, I could go in and add columns here. I could also delete columns out. So you can change a lot of things here. And you'll know that when you create this table for the first time and you don't have any data in it, you're not going to be able to go into browse here. So you actually have to go over to insert here, and you need to just add some data in. So just for the heck of it, let me actually just do this here. So the ID, I think we want to put 2 there, although I think it would auto increment, and 0 and 0. And we're just going to go ahead and add those. Okay, my web interface here automatically now incremented that row. And then, since it would be your first time, you're not going to see that browse, but after you do insert that row, that first row, you should then be able to go here, and you can also change these values here. So if I change that to like 100, I change that to 100, and I can go back here, refresh the web interface, and I see 100 there now. Okay, so now that we have the full database, that's pretty much the only thing you really need to do here. Okay, so we've created a SQL database with a new table. So now we've got this, and this is where we're going to store information. So the other way around too is if I changed this over here to like 200 now, and went here and just click browse to refresh this, you now see that there's 200 in there. So you can also use this to sort of keep an eye on your tables and your database just while you're debugging. Okay, so I think that's pretty much all there is to talk about the SQL database and table. Okay, so now let's get into some of the PHP code. Okay, so we'll come back to the database here as we are making changes to it from the web interface and from the ESP8266. So now let's get into the code that's running on the web side. So let's open up File Manager in the web root. Okay, it launches this File Manager interface. And right in the public HTML folder, we're going to create a new folder. I have it called Micro. And then this project is in ESP Part 3. And you'll see that we have 3 files here. These 3 files are all that's needed for this example, and they're all written in PHP. So let's go ahead and talk about the first one here, which is from Micro. So let's click Code Editor there and open this up. And this is the code that is called from the ESP8266. So we're doing an HTTP GET on this piece of code. So you'll see here that I have an example link here to it, which would be kevindara.com, micro, ESP part 3, from micro.php, and then we got some funny business going on here, which is how we're able to actually pass in data to this piece of code. So what we're basically doing is passing variables through the URL. So again, we're not talking about anything very secure here. So, our sensitive data could be sniffed out by hackers, but we're not going to get into that too much in this video. So anyway, this is all written in PHP, which is probably going to be new for most of you, but it's pretty straightforward. And if you have any questions or anything, you should be able to Google it and find an example on something that's pretty close to what you're trying to do. Okay, so basically what this does is the first thing it does when you call it is it goes through and loops through your URL and picks off the variables. So we're passing in 2 variables. One is this unit equals 1, and one is this sensor equals 1, 2, 3. So those are the 2 variables we're passing in. The unit is basically the ID of the ESP8266. So if you had a whole bunch of things out there, you would want to give each of them different IDs so that they were changing different rows within that table that we just talked about. So the first thing we do though is loop through there, and you can see that as it loops through there, we can check the key for unit, and then if it is true, then we go ahead and store whatever that value is into a variable. So we're basically declaring a variable, and that it's got a kind of a weird way of doing that in PHP, and that's why we have this little $ here with unit. So that is our variable to store this 1 when we call that variable. And the same thing for the sensor. So it's storing this 123 in for the sensor variable. So if we actually went and called this, I've got it over here and I'll refresh it, we can see what the response is, and we'll talk more about that. But you can see that it does work, and we are passing that URL into this piece of code and able to sniff out those variables. Okay, so let's go back here. The next thing we do, now that we've got the variables from the URL, we go ahead and create the connection to the SQL database. So that's what we do here. And to do this, we set up a new variable, MySQL I connect here, and we have these 4 things here we have to put in. First is the server location, which is a local host. This piece of code is running on the same server as where the SQL database is, so you just put localhost. And then that user we created, we put that in right here. Then the password for that user, and then the actual database. Okay, not the table, the database. And then we have a little bit of error checking here to see and make sure that we did connect to that database. Okay, so now we're connected. The first thing we want to do is send in that sensor data into the database. So we do this little SQL command here. So it updates the ESP table. So now we're updating the table, and we set the sensor column equal to the sensor value that we pulled in from the URL, where the ID is the unit. Okay, so it's kind of confusing, but basically what we're doing here is setting the sensor column where the ID row is 1. Okay, so this is a nice way to visualize it. So the ID is 1, set the sensor to whatever that value is. Okay, so we can test this out here. So the sensor value, if I change this to like, how do I want to do this? How about just 5? Okay, and then we go back here and refresh it. The sensor value is now 5. Okay, and that's what that little piece of code is doing right there. Okay, so moving on. The next thing we do is grab the time. So we're connected to the internet. We've got a great source for the time. So the first thing we do is set the time zone here, and I'm on the East Coast. So I set it here to America/New York. And then create a new variable and set this up and format it for the time, which is GI, and that gives me a nice just standard 12-hour format. So if the time is, I don't know why it's got that. If the time is 1:23, I just get 1, 2, 3 out of it. Let me save that. Okay. So then what we do is pull out the entire table that this is here. So we want to pull out all the entire table out, and what we're trying to do is get this LED data off of it now. Okay, so if we go in here, this will make more sense here in a second. So we're basically querying the table, pulling out all of the data, and then we're going to loop through it. And then as soon as the ID equals the ID that's in this variable here that we called, because that's really the only information we're interested in, we go ahead and create new variables for D1 and D2, where D1 is equal to the LED data. So we have the row LED, and then the row sensor. Okay, so now we've got those 2 pieces of data. And then we can echo, which is basically like a serial.print command, out of this piece of code. And we can print out the entire string here, which is _T1, and then our actual variable T1, which is the date, or the time, and then 2 hashtags, which are used to parse this out. So once the ESP8266 sees this, which we're going to talk about, it's going to first look for the T1, and then it knows that the following data is the time, and then it looks for the 2 hashtags, and then it knows it's done, and then it starts looking for the D1, grabs D1, the 2 hashtags, and it's done. Then it looks for the D2, and then it does the same thing. So it grabs that data out, 2 hashtags, and it's done. Okay, and then when we go and run this, here we can see that. So we see the T1 and we see the time. So it's 5:51, 2 hashtags. D1 is equal to 100, which it is, the LED there. And D2 is equal to 5. which it is. Okay, so that's all there is to it. It's as simple as that. And obviously, you know, I'm kind of just giving you, I'm trying to keep this as simple as possible, but it can get pretty in depth. So once we're done with that, then I added a nice little bonus feature here to this code, which is how I'm actually able to send text messages. So if you see this little piece of code here, if the sensor value is ever greater than 200, we want to send a text message. But I'm not actually sending a text message. I'm actually sending an email. But in case you didn't know this, you can send text messages via email, via like an email address. So like if your phone number is, if your carrier is through Verizon, then it is your phone number at vtext.com. That is your address. So it's the same thing for AT&T, Sprint. You just Google it, how to send text messages via email for your carrier, and you'll figure out how to do that. And you just put that in here. So it's mail at the address here. And then these things like the subject, and then you can put your sensor data, and then, you know, who it's from. So that's exactly what I got going on here. So I got the alarm, whatever that sensor data was, and the unit ID. Okay, so that's all there is to the from micro.php code. This is what's called from the ESP8266. So now let's get into the web interface code. Okay, so now we're going to talk about how to create that web interface, and that is all written in this interface.php. So let's go ahead and open that up in the code editor. Again, it's pretty straightforward. There's not a lot of code here, but it can be a bit confusing if you're new to PHP. So let's go ahead and walk through this. The top section here is all used just to refresh that page every 15 seconds. So that's how you set it here with the 15 there. So that automatically refreshes the page every 15 seconds. We're not doing any kind of like real-time polling or real-time data interaction with the web here. So that's why we actually have to refresh the page. Again, written all in PHP. So that's kind of just a quick and easy way to do that. Okay. The rest of the code down here should look somewhat familiar because it's the same code that is on the from micro.php. And basically what we do here is connect into that SQL database and then check the connection. So same exact connection there, check it, and then we pull out the whole table here into result. And then this line of code here actually prints off that nice text here at the top, the ESP8266 demo. So that's what that does there. And then what we do is draw out that table. So you can change, you know, the way the border looks. You can change what you want those column labels to be. So that's what this is doing, ID, LED, sensor. And then we loop through the entire table and draw out all of the data. It gets a little tricky in here because what we're doing there is drawing this button here, this change button. So let me explain that. So we go through it. We have to grab whatever the current unit ID of the row is, and the reason we do that is to know where we're going to change. So when you click this button, you're going to actually call the change SQL code. Let me actually go back here. You're actually calling this change SQL.php code here, and what that does is it takes whatever is in the box. So let's just walk through it. So it shows you, our column is LED. The current LED is whatever the data is in LED. Okay. So it is going to actually, I think I'm kind of jumping around a little bit here, but we want to first show the row ID, and that's what this is here, the 1 there. Okay. And then we set up some of our own variables here, which are used for that change button. Then you have the current LED, and then you echo this here, this form action change. Okay. this form action, which is for that button. So when you click that button, it's going to trigger this action, call change SQL.php, and it's a post, meaning that we're going to pass along some variables, and we're going to pass along the value at the current LED, which is whatever's in that text box there. Okay? And then we also pass along the unit because we need to know which row to put it into. So we grab the unit ID. Okay? And then we also grab the column because we need to know which column. So we've got the value, we've got the row, and then we have got the column. Okay? And then we set up the button itself. Okay? So I've got the value here for change. All these other things I wouldn't worry about too much, but we've got the value here, change, and then we display in that final one here the actual value for the sensor. So that's this row sensor. Okay. So here's one thing though. You might be asking, well, where do you display the LED? Well, that's actually right here. See how these other ones are all hidden? This one is the actual text box itself that's sitting there. So that creates that entire thing. So we're actually creating this little box inside there that lets you change it with a button. Okay. There's different things you can do too. You can put like little radio buttons. You can do all kinds of cool things there. You could put multiple buttons within a column if you needed to. Okay. So, and what the nice thing about this is if I were to make a change here, I just have to hit save and then it'll automatically update that and I can go in and refresh this. Just make sure you don't go and save over your work too much because then, there's no way to go back and undo everything. So, but anyway, yeah, that's it. So then we echo out that entire table and it's done. So when we click that button, we pass along, we do that post, and we pass along all of those variables to change SQL.php. So let's jump over to that now. Okay, so let's open up change SQL.php. And very little code here because all it's doing is bringing in, it's handling that post request from the interface.php. So we're passing in these three variables here. So you see we've got the post for the value, the unit, and the column. And so the value was that LED value. The unit ID would be normally the one that we're actually testing with, which is the row, and then the column, which is the LED column. So the value, the row, the column. And then we go ahead and connect to the database as usual, check the connection, and then we do this command here and update. So we're setting that column, the LED column, with the value where the ID, the row, is the unit that comes in as that ID. Okay, that's as simple as it gets, really. And then what we need to do is jump back to the interface.php, and that's what this does here. So header, location, interface.php, and that jumps you back to the interface. If you didn't have this, in fact, we could test that. Let's try that. If you didn't have this, let's go ahead and hit save on that. So here we are in the web interface, and if we went change, let's just change it to 101, change. We're stuck now in the SQL.php, or the change SQL.php. So we need to jump back to the interface. So I'll go ahead and change that back up, and I need to hit the back here, okay, and go ahead and hit change again, and now we're back. Okay, it all happens seamlessly. You don't even notice it. Okay. That is all there is to the change SQL.php. So I know I kind of rushed through that a little bit, but that's all there is to the web interface side. So now let's jump over to the Arduino code. Okay, so here is the Arduino code. It's the same exact code as from my previous two videos. I did have to change a few things. The board I used for this example was a bit different from the setup I had previously, so double check, that your RX and TX going to the ESP8266 are the same. Don't just drop this in and load it up, because you could have some problems there. Obviously, you set up your SSID and password to whatever yours is. And I'm not going to get into how all of this code runs again, because we already covered that in an insane amount of detail. So for this video, I just want to talk about the changes to support this example. Okay, so the first thing you'll notice here is that we've got a new URL. So we're not connecting over to the ThingSpeak server. We're connecting now to wherever your PHP code lives, which is this kevindera.com micro ESP part 3 from micro.php. Remember, we're only communicating to from micro.php, and then we've got our question mark and then unit equal, and then this is whatever your unit is going to be. I think I have a variable here for unit. Where are my global variables? There we go, unit ID. So if you were to create 100 things, you would give each Arduino its own unit ID, and then make sure you set up your database or your database table to have as many rows as you do IDs, so that everything matches up. Okay, so we've got that. The first thing you need to do though in this code is go over to your Connect ESP, because you're no longer connecting to that ThingSpeak. You do need to change which server you're connecting to. So we're just connecting to kevindera.com on port 80. So you just change that. That's pretty straightforward. That's the only thing you have to change there. And then a few minor things are changed throughout there. We added a few variables in now to handle the sensor value, sensor readback. That's what we're reading back from the web, because we are changing a sensor value here and then sending it out and then reading it back. So we're able to track all of that. Let me go back down here. We're going to jump into the loop here. So you see that the sensor value is just doing an analog read, so value from 0 to 1023. And then we connect to web host, which is a new function, but it's really just a modified connect YouTube function. So we go there, we connect to the web, we post up the sensor value, and we pull down the LED value, and then we do an analog write to pin 3 of whatever that LED value is, wait 5 seconds, and do the same thing again. So, it's extremely easy once you get it all set up. So let's go to, actually, before we go into Connect Web Host, I want to show you a few new keywords. So we talked a little bit when we were going over the from micro code that we've got keywords for the time, T1, for D1, for D2, and then we've got the double hash. Okay, so those are those keywords. All the other code is the same. I apologize if there's some comments left over talking about YouTube stuff in here, but it's all pretty much the same thing. One thing I did change here is that now instead of using a fixed length array, I'm using strings, which is probably not the greatest idea here with the Arduino, because we're creating this this string here, URL with packet, and this is the URL web host. So we're building up this string to go out to the ESP8266. So we start with this one, which is like the base URL, and then we build it out with our variables. So we do this, and then we build it out with the string version of our ID, so plus equal to that, and then our sensor, we have to say what the variable name is, sensor, and then the string of the sensor value, and then the payload closer, which is this guy here, this big long thing, the HTTP 1.0 carriage return new line feed twice. That's just a weird quirky thing needed by the ESP8266. Okay, so we build up that entire thing, and this is all done, with dynamic memory, so it's not as stable as using like a fixed length array, which is what I probably would have normally done here, but this works for now. So anyway, you do build that up, and then this code's the same thing here, which is basically running through now the URL with packet, and you'll notice now that instead of size of, it's doing this dot length thing. Okay, so it's getting the length of that string, working through it, building up the payload. And the reason I didn't just use URL with packet instead of, this payload is because I didn't want to go back through the connect ESP code, when it actually loops through this and sends out this payload to the ESP. So we're going through that. We build up the payload. Okay, same code as before. The payload size, okay, that's all the same. And then we go in, and then if we do get a positive connection to the ESP, same thing as before. And if you go through this and watch my old videos, I do talk about this. The ESP goes in, it connects to the website, to kevindara.com, that server, checks and makes sure it's connected. Then it sets up what it's going to send, gives it the payload, goes through, and if it waits for this little caret sign here, then it gives you a ready to send, and then it goes through. Sorry, I'm kind of rushing through this here. And as soon as it gets the keyword send OK, then we know it's sent. And then it will return a 1, and we could jump in then and start getting our data back. So at this point, we should expect this to be returned. And what we're basically doing here is we're going to look for the T1, the data, double hash, D1, data, double hash, D2, data, double hash. Okay, and it goes through the same exact thing as before. And we have new variables here for the size of T1 and the data for T1. Okay. Or, sorry, I had that backwards. The data goes into the first byte in that array, or actually technically the second byte, and then goes through it and calculates the size and puts that into then the first byte. So it's the same thing as I had before. So that's for T1. It does the same thing for D1, and then it does it again for D2. Okay, and as soon as it gets T1, D1, and D2, it then looks for the link disconnect keyword, and then it's done, found data, disconnected, do a serial dump, and now we go and do a print of our time here, which I'm not going to go into detail on. We grab our time, we show the LED number. I have a little bit of code here that goes through those ASCII characters and converts them into an integer, okay, which is pretty straightforward, just loops through it. I've got a new variable for a multiplier array, which knows that it goes 1, 10, 100, 1000, and so on, and multiplies that up, does the subtract by 48 to strip out the ASCII character, and then we print out the LED value, okay? Then the next thing is for the sensor value, same kind of thing here, loop through it, do the multiplier, decoding of that ASCII character into an integer, and now we have our sensor, and that's it. Okay, then we jump back here, we've got our integer values, and we can now do something with those. So that's all there is to it. I'm going to have this Arduino code available for download. Again, I'm going to take down all of my PHP code, so that's going to be kind of up to you to host that somewhere and modify it to your project. But hopefully this gives you a better idea of how that whole garage door monitor system worked, and I hope this video helps you. So thanks for watching.